Hello everyone, welcome to my YouTube channel SGKmistry Lectures. In this video, we will be solving 50 multiple choice questions on the topic chemical kinetics. The explanation of this particular chapter has already been done and the video has been uploaded. Now, the 50 selected multiple choice questions from this entire chapter will be explained here. How to solve these questions as well as even the shortcut tricks will be explained. So without much delay, let us begin with the first question. For a reversible reaction, A plus B gives C plus D. The graph for rate of the reaction with time is given below. So you need to mark the terms here P, Q and R. So here the rate is given. Okay, let me use some other color. Okay, so this is the rate along the y-axis. And here we have the time along the x-axis. Okay, so now you need to identify this P, Q, and R, what it denotes. So it is very clear from the graph that here the rate of the forward reaction is equal to the rate of the backward reaction in case of R. So without any doubt, you can select that R represents equilibrium. So here we have R equilibrium. Here also we have R equilibrium, whereas in the other two options, we don't have R representing equilibrium. So you can easily remove these two options, that is option C and option D. Now let us look into option A and B because we have only these two options to be studied now. Now you see here in the graph, you can see in the beginning, let us look at P. So you can see that the rate along with the time, it goes on decreasing, right? First it was more, then it goes on decreasing. Whereas for Q, first it was 0, then it goes on increasing. So we know that the rate of backward reaction when you consider, so first we are considering forward reaction and then we have backward reaction. So forward reaction and backward reaction when we consider, so here you see, first there will be more reactant, then slowly what happens? Slowly the reactants will form products. So forward means reactants giving products, right? So first there will be lot of reactants. So rate, then what happens? Slowly it goes on decreasing. The rate goes on decreasing with time. Now, when you're talking about the products, in the beginning, the products will be nil, right? So backward reaction rate will be nil. So then what happens as and when the products are formed, whenever we are talking about reversible reaction, then slowly the rate of backward reaction increases as the rate of forward reaction decreases. So it is very clear from the picture that the P represents rate of forward reaction, whereas Q represents the rate of backward reaction because it is starting from 0, then goes on increasing, right? So the correct answer is option B. Coming on to question number 2. For a reaction, P plus Q gives 2R plus S. Which of the following statements is incorrect? So now what we can do is, whenever such questions are given, okay, we need to write the rate for this particular equation. Okay, now we can easily write it as the rate will be equal to minus d of P by dt is equal to, again, Q is a reactant, so minus d of concentration of Q by dt is equal to, so this is also, these all are equal to the rate. So 2R, it is a product. So whenever there is 2 coefficient here, we have to write it as half concentration of R divided by dt, okay, is equal to, again here there is no coefficient, so d of concentration of S divided by dt. So this is the rate. Now you look at the options, rate of disappearance of P is equal to rate of appearance of S. So P and S, right? This is disappearance because for P we have used a minus sign, for S there is plus sign. So yes, appearance and disappearance. So this is the right statement. Rate of disappearance of Q is equal to 2 into rate of appearance of R. It is not 2 into, it is half of appearance of R. Right. So this is incorrect. This particular option is incorrect. Now the question is which statement is incorrect they have asked. So it is option B. You can check the other options. Rate of disappearance of P is equal to rate of appearance of Q. Yes, these two are equal. Rate of disappearance of Q, this part, is equal to half into rate of appearance of R. Yes, that is also correct. So we need to identify the incorrect statement. So option B is the right answer. Next, question number 3. For the reaction N2 plus 3H2 gives 2NH3, how are the rate of reaction expressions interrelated? So again, let us try to write the equations for rate. So rate is equal to, again, N2 and H2 are the reactants. So minus d of concentration of N2 divided by dt is equal to, here coefficient is 3, so it will be 1 by 3, again minus concentration of H2 divided by dt is equal to, here it is 2, so 1 by 2 concentration, d of concentration of NH3 divided by dt. So change in concentration of NH3 by change in time. That is what is meant by this d of concentration of NH3 by dt. So now look at the options. We have to only observe the relation between that of hydrogen and ammonia. Only this we need to observe. So look at the options. Here minus 1 by 3 dH2 by dt is equal to half into dNH3 by dt. Yes. So here you can easily see that option A itself represents this particular relationship. So without any doubt, you can easily select option A as the right answer. Next, question number 4. Consider the reaction 2N2O4 gives 4NO2. Now, here they have given some constants, that is K and K dash. So first, let us try to write the equation for the rate. So rate is equal to, here there is 2. So it will be minus half into d of N2O4 divided by dt is equal to, here 1 by 4 concentration of NO2 divided by dt, right? Now, what is given here? Minus d of N2O4 by dt. Minus d of N2O4 by dt. This part, okay, this part is represented as K. Now, what is remaining? Only half is remaining, right? Half into this entire part, whatever I have circled, that is K. Correct? I hope it is clear. Now, here d of N2 by dt, this is represented as K dash. So now what is remaining? 1 by 4 K dash is remaining. Now we can do the simplification. Here 2 ones are, 2 twos are. So 2K is equal to K dash, or K dash. Yeah, so this, if I take it here, you can see whichever, yeah, 2K dash, that is not there. So K dash is equal to 2K. Yes, we have this particular expression, right? Let me erase this. So you can look into the option. So if the option shows one of it, we know that yes, K dash is equal to 2K. We have already got this. So it is option this, K dash is equal to 2K. Option B. Okay, next. Question number 5. For the reaction, 2NH3 gives N2 plus 3H2. If already they have given all these, okay, then the relation between K1, K2 and K3. So now let us again write the equation for rate is equal to, so we have 2NH3, so minus half d of concentration of NH3 by dt is equal to, here we have N2, so d of N2 divided by dt. Here we have 3. So 1 by 3 concentration of H2 divided by dt. Now, minus d of NH3 by dt. This part is represented as K1 into NH3. Right? And already we have this half. So let me write it like this. Next. Here you see in the question, dN2 by dt, this entire thing is represented as K2 into concentration of NH3. This is from the question. Okay. Next, dH2 by dt, this part is represented as K3 into concentration of NH3. But then we already have this 1 by 3. Okay. So we got this thing now, this relation. Okay. Now, this NH3 is common in all these three. So I can just remove this NH3. Now I have half K1 is equal to K2 is equal to 1 by 3 into K3. Now, here what you can do is already see. Now there is nothing like with fractions when you look into the options. So what you can do, let us try to make it the whole numbers as much as possible. So suppose I multiply this by 3. Okay. So now I have 3 by 2 K1 is equal to 3K2 is equal to 3. 1 by 3 into 3 will give you 1. So K3. Correct? Now 3 by 2 is nothing but we know it is 1 are 2, 1. So 5 are right. So it is nothing but 1.5. So 1.5 K1 is equal to 3K2 is equal to K3. So we have 1.5 K1 into is equal to 3K2 is equal to K3 as the correct answer. Okay. Next, question number 6. For a reaction R gives product, the concentration of a reactant changes from 0.05 molar to 0.04 molar in 30 minutes. What will be the average rate of the reaction in minutes? Here also very simple. We know that R average, the average rate is given as change in the concentration divided by change in the time. Change in the concentration of the reactant by the change in time. Now we know that, or delta also you can use, because since it is the average, okay, you can, instead of D, you can write it as delta. Okay, delta R, delta T. So delta R, so we know that change in the concentration of the reactant, 0.05 molar to 0.01 molar. So 0.05 minus 0.01 you need to do 0.05 minus 0.04, and delta T is already given, that is 30 minutes. So 0.05 minus 0.04 is 0.01 divided by 30. So direct substitute, direct calculation. So you can shift the points 1, 2. Here you can do the shifting of the points. So 1 by 3000. Okay, so we have one more. So 3. Okay, you have 0.00033. Okay, so you can shift the points 1, 2, 3, 4. When you shift the points this side 4 times, so you get 3.3 into 10 to the power of minus 4. Again, what is the unit? Here, molar in the top. Okay, whereas here it is minute. So, mole per minute. Okay, so 3.3 into 10 to the power of minus 4 mole per minute is the right answer. It's just the direct substitution and the division. Next, nitrogen dioxide dissociates into nitric oxide and oxygen as shown in the given equation. Okay, if the rate of decrease of concentration of NO2 is 6.0 into 10 to the power of minus 12 mole per liter per second, what will be the rate of increase of concentration of O2? So now let us write the equation for the rate. So rate is equal to half minus half d of NO2 by dt is equal to, now, we are only concentrated about oxygen. So I'm going to write only for oxygen, d of O2 by dt. This is the first thing what you're going to write. Now, if the rate of decrease of concentration of NO2 is already given, that is 6.0 into 10 to the power of minus 12. So, let us substitute this value. So, we have minus half into, so rate of decrease is already given. So, no need to again take it as minus. Already it is mentioned as rate of decrease. So half into 6.0 into 10 to the power of minus 12 is equal to, so how much you have to find out? See, decrease is given. What will be the rate of increase? So these both are equal. This is rate of decrease of NO2 is equal to the rate of increase of O2 according to this rate equation, whatever we have written. Rate equation in the sense, this equation for rate, whichever we have written, we know that this is equal. So now let us do the calculation. So we have 2 ones are, 2 threes are. So the correct answer is 3 into 10 to the power of minus 12 mole per liter per second. Very simple. So correct answer is 3 into 10 to the power of minus 12 mole per liter per second. Next, for the reaction, 2N2O5 gives 4NO2 plus O2. Rate and rate constant are, so rate is given, this is rate. Rate constant is nothing but K respectively. The concentration of N2O5 in mole per liter will be. Okay. So now you can see here K value is 3.4 into 10 to the power of minus 5 per second. So when you look at the unit, we know that it is a first order reaction. So this is what is understandable from the question that is given. Right. Now rate is given as 1.02 into 10 to the power of minus 4 mole per liter per second. Right. Now, we know that rate is equal to K into N2O5 square. This is a rate equation. Okay, we know that it is first order reaction. Now, we know that in this case, not the square, I'm really sorry, to the power of 1 because it is first order reaction. Okay, so now let us try to do the calculations. So what you need to do is, now we have K value, we have rate. We only need to find out the concentration, that is N2O5. Since using this value of K, we know that it is first order. So no need to write, although in the equation it is 2, we need not write 2 here because we know that since it is first order reaction, the rate is directly proportional to the first power of the reactant. Okay, so that's why I have taken it as to the power of N2O5 concentration to the power of 1. Okay, so now do the substitution. So we have concentration of N2O5 is equal to rate by K. So rate is 1.02 into 10 to the power of minus 4. K value we know 3.4 into 10 to the power of minus 5. Right. So now we have the value. Okay, so this also I can make it as, see, if I shift the point this side, here if I shift the point this side, so 102 into 10 to the power of minus 6 divided by 34 into 10 to the power of minus 6. So these both cancel. So 102 by 34. So we have 3 times, right? 34, 3s are 102. So we have the concentration of N2O5 is equal to 3. So 10 to the power of minus 6 and minus 6 has cancelled. So it is nothing but 3 mole per liter. So correct answer is option B. Okay. Next, question number 9. A reaction in which reactants are converted into products, P, follows second order kinetics. So here they have given clearly it is following second order kinetics. That means it is a second order reaction. If concentration of R is increased by 4 times, what will be the increase in the rate of formation of P? Such type of questions are very important. So you should know the relationship between how the increase in the concentration of the reactants will bring about the increase in the concentration of the products. So we know that R gives products, reactant give product. So rate is equal to K into concentration of R. We know that when we are writing the rate equation, rate will be equal to the rate constant into concentration of R. Now we know that it is second order reaction. So of course it will be R square. So now concentration of R is increased by 4 times. So now what happens is 4 into R square will be equal to 4 squares is 16. 16 R square. So of course the product formed will be 16 times more when compared to the initial. That is in the initially we have R. Now it is increased by 4 times. So the product formation will be increased by 16 times. So the correct answer is option C, 16 times. Next, question number 10. The rate of a gaseous reaction is given by the expression rate is equal to K into A to the power of 2, B to the power of 3. The volume of the reaction vessel is reduced to 1/2 of the initial volume. So now we know that the volume is reduced to half of the initial value. So that means when the volume is reduced to half, the concentration becomes double. Okay, so A now becomes 2 into A, whereas B now becomes 2 into B because of the reduction in volume to half of its initial volume. So now what will be the reaction rate as compared to that of the original rate? So we have the substitution now K. Instead of A, we need to write now 2A. So square, keep it as such. Instead of B, I'm writing 2B. Keep the cube as such. So K into 2 square is 4. So of course we have 4 into A square. 4 into A square. And here we have 2 cube is 8. 8 into B cube, right? So now we have 4 into 8. That is nothing but 32. So 32 into K into A square into B cube. Now initial was K into A square B cube. Here we have K into A square B cube. Now how much is more? 32 is more. So this they have given. See, reaction rate as compared to the original rate A. This is taken as A, this entire term. So now we have 32 into again this entire term, which is nothing but A. So 32A. So correct answer is option D, 32A. Next, question number 11. The rate of formation of a dimer in a second order dimerization reaction is 9.1 into 10 to the power of minus 6 mole per liter per second. Okay, so a dimer is formed. So of course, you're taking two such molecules which will form a dimer, that is A2. Correct. Now, second order dimerization is again mentioned. So we know that we can also write the rate equation. Rate is equal to K into A to the power of 2 because second order reaction. So of course, the power should be taken as 2. Okay. Now what else is given here? 0.01 at 0.01 mole per liter monomer concentration. So the concentration of the monomer is already given. And what else is given? Yes, the rate of formation is given. So what will be the rate constant? Now rate is given, concentration of the monomer is given. You need to find out the rate constant, that is K. So K will be equal to rate by concentration of A square. Now rate is nothing but, it is given 9.1 into 10 to the power of minus 6. Concentration of A is given 0.01. So you have to take square of it, right? So we have 9.1 into 10 to the power of minus 6. Okay. So we have 0.01 square is 1 into 10 to the power of minus 4. So now 9.1 by 1 is 9.1 itself. 10 to the power of minus 4, when I take it above, it becomes plus 4. So we have 9.1 into 10 to the power of minus 6 plus 4, or 9.1 into 10 to the power of minus 2, right? So what will be the unit? So we have same, liter per mole per second. So we have option A, that is 9.1 into 10 to the power of minus 2 liter per mole per second. Okay, very simple. Just you need to know the equation to be written with respect to the rate law, as well as also you should be able to identify which substitution has to be done for rate constant as well as rate of the reaction. Proper substitution has to be done. Okay. Now, what will be the rate equation for the reaction? So they've given a reaction like this. If the order of the reaction is 0, so order is mentioned as 0. So that means the rate is independent of the concentration of the reactants. So zero order reaction, you already have, you know that I've already explained in my previous video. So of course, it is very simple to select among the options. Rate is equal to K, because in a zero order reaction, the rate is independent of the concentration of the initial concentration of the reactants. Okay. Next, question number 13. For a reaction, 2NO plus 2H2 gives N2 plus 2H2O. The possible mechanism is, so they have given the mechanism, the various steps that are there in the reaction, I mean in the mechanism. Sorry for the some words are not clear, but I'll just explain it. So now, whenever the mechanism is given, you should know that we are looking at the slow step or the rate determining step. Slow step is the rate determining step. Correct? So this is what you need to know. Now, how do you write the equation for the rate? Now you look, whenever you're writing the equation for the rate, we are only looking at this rate determining step. So rate is written as rate is equal to rate constant K into concentration of N2O2 into concentration of H2, because we are only looking into the rate determining step. So we have this particular rate equation for in this formula, in this option only, whereas in all the other options, we don't have this option. Okay. Then what will be the order of the reaction? Of course, the order will be 2 because this itself is the rate equation. That means here it is 1 and 1. So 1 plus 1, order is 2. So we have the option B as the right answer. Next, question number 14. Rate constant of two reactions are given below. So K is equal to 5.3 into 10 to the power of minus 2 liter per mole per second, and K is equal to 3.8 into 10 to the power of minus 4 per second. So you need to find out based on the units which order reaction we are talking about. So how do you calculate the unit for a rate constant? So concentration by time into 1 by concentration to the power of n, where n is the order of the reaction. That will give you the units for the rate constant. So concentration, we know that mole per liter by time second. Now 1 by concentration is again mole per liter. Mole per liter cancels. So second inverse. So here I've taken n is equal to 1. So for first order reaction, it is S inverse. So second one is first order. Here we have first order. Here we have first order. So you remove these two. Now we have only two options, second order or zero order. Let us try for second order. So concentration by T into 1 by concentration to the power of 2. So mole per liter by second into 1 by mole per liter square. Square and this one will cancel. So we have mole inverse, liter inverse. When it comes to the numerator, it becomes liter to the power of 1. Second, when it is downward, when it comes to the numerator, it becomes second inverse. So mole per mole inverse, liter, second inverse. So we know it is for the second order reaction. So we have first one as second order reaction and the second rate constant, it is for the first order reaction. Next, question number 15. Find the values of A, B and C in the following table for the reaction X plus Y gives Z. The reaction is of first order with respect to X and zero order with respect to Y. Okay. So first let us write the rate equation. So K into X and rate is equal to K into zero order with respect to Y. So this is what is already known. Now, this you have to keep it in mind. Now let us look into the table. See, X with respect to X, the reaction is of first order. Now you see here 0.1. Here the rate was 2 into 10 to the power of minus 2. Now here the rate has increased. It has become double. So of course, this also has to be double because the rate is first order with respect to X. Whereas with respect to Y, it is zero order. That means the rate is independent of the concentration of Y. So since the rate has doubled here, so even the concentration here has to be doubled. So A will be double of 0.1, that is 0.1 into 2. So it should be 0.2. So we have only two options with 0.2. Now let us look into the next. Okay. So here you see, if this is 0.2, now you look at second and third. Now you can see the concentration has been doubled from 0.2 to 0.4. Here also the rate has to be doubled because with respect to X, the rate is first order with respect to the concentration of X. So this has to be doubled. So this will be 8 into 10 to the power of minus 2. So look at the options. Here we have 8 into 10 to the power of minus 2. Here we have 2. So this is wrong, and this is wrong. So of course, option A should be the right answer. Now you can, if you want, you can even confirm. So here again, the rate becomes 2 into 10 to the power of minus 2, which corresponds to 0.1. See here, the first value. So 0.1 mole per liter. Okay. Yes. Now let us go to the next question. That is question number 16. Yes. Now what does it say? For a chemical reaction, X gives Y, the rate of reaction increases by a factor of 1.837 when the concentration of X is increased by 1.5 times. Okay. So now you look at the question, the order of the reaction with respect to X. So this is what you need to find out. Now let us look into the rate of the reaction increases by the factor. So R2 by R1, the rate with respect to the concentration. So X2 by X1, how it has changed. Now this to the power of N will give you the order N. N is equal to the order of the reaction. Now R2 by R1, what is the change in the rate? That is 1.837. X2 by X1, the concentration of X is increased by 1.5 times, 1.5 to the power of N. So you need to remember this particular equation. Whenever two different rates and two different concentrations are given, you need to find the order. You can use this particular equation. Here, two different values are not given, but the change is given. So you can directly substitute the changes. Now, finding N as such, it takes a long time. Finding the square root or finding what is the exact value of N, because 1.5 is known. We need to find out it is raised to how much to find out what is the value. Now you can use an approximate method. 1.5 into 1.5, we know that it is 2.25. Right? So 1.5 square is equal to 2.25. Correct? 1.5 to the power of 1 is 1.5 itself. Now, what is the value? 1.837, which is in between these both. Correct? Between this 1.5 and 2.25, we have 1.837. Now, you have to look into the number between 1 and 2 among the options. See here. So, 1 cannot be the answer. 2 cannot be the answer. 2.5 cannot be the answer because it is above 2. So, of course, the answer is option B, that is 1.5. Okay. So, this is an easy trick to find out the answer. Instead of going for long calculations, just by approximation methods, you can find out what is the right answer. Next, question number 17. For the reaction A plus B gives products, what will be the order of the reaction with respect to A and B? So you need to look into the values now. So look at A and B values. So let me just mark it in the graph, it's in the table itself. So A and B values, we are looking carefully at these values and how the rate changes. Okay. Now, let us try to write a simple equation because we don't know the order of both of them. Like we don't know what is the order with respect to A as well as what is the order with respect to B. So let us take it as X and Y. So rate is given as K into A to the power of X into B to the power of Y. So we have to find out what is X and Y. Now, you see here 2.5, this becomes 5, doubled. Here it was 3. Here it was again, now you can see it is doubled. 3 became 6. 10 to the power of minus 5 is same. Even for A, in the first case, it is doubled. Now you see here 5 into 10 to the power of minus 4. 4 into 10 to the power of minus 3. So now, in the first case, both the concentrations have been doubled. Both the concentrations of A and B have been doubled. Now you see here for first one. Now how the rate changes, that is what we are going to see. So how the rate has changed. Now it becomes, this is the rate 2, this is the rate 1. So let us take the ratio. 4 into 10 to the power of minus 3 divided by 5 into 10 to the power of minus 4. So this can be written as 40 into 10 to the power of, if I shift a point this side, it will become 40 into 10 to the power of minus 4 divided by 5 into 10 to the power of minus 4 cancels. So 5 ones are 5 eights are 40. So the rate of change when both of these are doubled is the change in the rate is equal to 8. Okay, the change in the rate of the reaction when both these concentrations of A and B are doubled, then the change is 8. So now we know that, okay, so 2 to the power of x, because it is doubled now, so I'm taking it as 2. First it was 1. Now since it is doubled, I'm taking it as 2. Again, y is also doubled, so 2 to the power of y is equal to 8. So 2 to the power of x plus y is equal to 2 to the power of 3, right? So 8 is nothing but 2 cube. So x plus y is equal to 3. This is what we got now. Now let us look into the next. See here, b is kept constant. 6 into, correct? Yes. Let me make it more clear. See, in the next step, b is kept constant. 6 into 10 to the power of minus 5. But a is again doubled. See, 5 into 10 to the power of minus 4. It has been doubled to 1 into 10 to the power of minus 5. So this is nothing but, if I want to make it, it's 1 minute. Yes. 10 to the power of minus 3. 1 into 10 to the power of minus 3. It has been doubled. Correct? So we know that this also can be written in the form of 10 to the power of minus 3 for much better clarity. So 0.5 into 10 to the power of minus 3 it will be, which is converted to 1 into 10 to the power of minus 3. So it is doubled. So A is doubled now. When A is doubled, let us see how the rate changes. Okay, so again we need to take the ratio 1.6 into 10 to the power of minus 2 divided by 4 into 10 to the power of minus 3. Now, this also I'll make it 10 to the power of minus 3 in the numerator. So, 16 into 10 to the power of minus 3 divided by 4 into 10 to the power of minus 3 cancel. 4 ones are 4 fours are, so 4. When A is doubled, not A, yeah, when A is doubled, B is kept constant. So when A is doubled, the rate increases by 4 times, right? So 2 to the power of x is equal to 2 to the power of 2. X is nothing, the 4 is nothing but 2 to the power of 2. So we have x is equal to 2. So now we have this particular equation, x plus y is equal to 3. So x I'll substitute for 2, 2 plus y is equal to 3, which means y is equal to 1. Correct? Now, x for A we had taken. So, x for 2. So, 2 with respect to A, 2 with respect to A. We have only these two options now. Next, we have y is equal to 1. That means with respect to B, it is the order is 1. So, 1 with respect to B. Here we have 2 with respect to B. So, all these options are wrong. So, option B is the right answer. Okay. Yes. With practice, you can do it still quicker. Quickly, you can solve this particular question. But since it was the first time explanation of this type of a problem, I explained it in detail. Okay. Let us go to question number 18. In pseudo-unimolecular reactions, both the reactants are present in low concentration. No. Both the reactants are present in same concentration. Wrong. One of the reactant is present in excess. Yes. So option C is the right answer. So very simple examples are the inversion of cane sugar, okay, as well as the acid catalyzed hydrolysis of ethyl acetate. So in all these cases, in both the cases, water is taken in large excess. So the reaction rate is independent with respect to the change in concentration of water, because overall there is no much change since it has been taken in excess. So that's why it is called as pseudo-unimolecular reaction. Next, question number 19. So here it is quite simple, easy to identify also. So rate is equal to K into NH3 to the power of 0. Here we have, again, let me write the order of each of these. Here 0 order reaction. Here we have 1 and 1, so second order reaction. Here we have fractional order reaction. Here we have first order reaction. Okay. So for first order reaction, just we have derived a few numericals before solving a few numericals. I had derived how you get this s to the power of -1, that is s inverse for first order reaction. So we know that for D it is 3. So look at the options here. We have D is equal to 3. For D it is 3. So you can easily remove the first two options. Now next, for first order reaction, we already have. For the second order reaction, so that also we have derived, right? So now if you want, we can again check for zero order and for the second order reaction. So the same formula is used: concentration by time divided by concentration to the power of n. So for first order, we already have second inverse. Now let us try for zero order reaction. Either you can memorize these units or you can quickly find it out. Okay, mole per liter by time into 1 by mole per liter square. This is for second order reaction. So we have mole inverse liter second inverse. This is for second order reaction. Now you see here, second order reaction is in B. So we have mole inverse liter second inverse into. So we have B2. Okay, so we have this. So you can easily remove this. But let us even confirm the other two. Okay, so next for zero order reaction. So mole per liter per second into 1 by concentration to the power of 0 is again 1. So we have mole per liter per second. We have mole per liter per second. That is 1. For A, we have 1. So here we have A1. Next for C, we have 3 by 2. So mole per liter by second into 1 by mole per liter to the power of 3 by 2. So we have mole 1 minus 3 by 2 liter minus 1. So already we have minus 1 here, 3 by 2. Then we have second inverse, right? So we have minus and minus here. For liter, we have half. Mole, we have, yeah, minus half. And then we have second inverse. So we have option D as the right answer. So this here minus and minus, this will become plus. So this here we have 1 minus 3 by 2. So since it is already it is minus here, when you take it to the above, it will become plus. So minus 1 plus 3 by 2 you get. So here L to the power of half, mole to the power of minus half, and then we have second inverse. I hope it is clear. Okay, so here we have for C, that is this particular L to the power of half, mole to the power of minus half, second inverse, that is 4. So C, 4. Next, question number 20. For a general reaction, X gives Y, the plot of concentration of X versus time is given in the figure. What is the order of the reaction and what are the units of rate constant? So whenever you have this, this particular graph, be very sure that we are talking about the zero order reaction. Okay, so this is the equation. So we have Y as the x-axis. In the y-axis, we have the concentration of R. Then we have this mx, and then we have C. So this is the intercept. Then we have mx, that is a slope. So this is for zero order reaction. Okay, so the answer will be zero order. And what will be the unit? So you just, in the previous problem itself, we have solved. That is mole per liter per second. So option A is the right answer. Next question number 21. For a reaction X plus Y gives Z, rate is directly proportional to X, concentration of X. What are the molecularity and order of the reaction? Okay, so here you can easily see rate is directly proportional to X, concentration of X, and there is no power as such. So we know that rate is directly proportional to X in the sense you can write it as rate is equal to K into concentration of X. Here nothing is given as power. So that means it is very evident that we are talking about the first order reaction. So order of the reaction will be 1. So only these two options we are checking. These two we are just removing it off. We are eliminating the options. What are the molecularity of the reaction? So already nothing is mentioned about any other mechanisms. It's just an elementary reaction. So how many molecules collide together to form the product? So here we know that there are two such reactants, X plus Y. So molecularity will be 2. So the correct answer is option A. Next question number 22. A first order reaction is 20% complete in 10 minutes. What is the specific rate constant for the reaction? Now, before attempting such questions with respect to the first order reaction, finding out the rate constant or the time, you should know certain log values. Okay. So log 2, it is very, very important. You should memorize this. That is 0.3010. Okay, this should be in the tip of your tongue, the log 2 value. Next, log 3 is equal to 0.4771. Log 4 is nothing but the double of log 2, that is 0.6020. Log 5, please make a note of this, log 5, 0.6990. And then you should remember log 7 value, that is 0.8451. Okay, so these values should be remembered, which will make your solving of the problems much easier. Okay, especially log 2, very, very important, because using log 2, you can find out the values of other related numbers. Okay, so 0.3010. Log 4 is double of that. Log 3 is 0.4771. Log 5 and log 7 values you need to memorize. Okay. So now let us try to solve the question. So first order is mentioned. So we know the equation K is equal to 2.303 by T log of A by A minus X. Right? A is the initial concentration. A minus X is the concentration of the reactant at time T. Now, first order reaction is 20% completed. So 20% out of 100 has been reacted. So how much is remaining? 80 is remaining. So we need to write the equation as A is equal to 2.303 by T log. Now, A initial concentration, we are taking it as 100 because since it is given in percentage, 20% has been completed. So 100 minus 20 will be 80, right? So now in 10 minutes, so time is given as 10. So let me substitute here itself. Okay, time is 10. Now here you can see in the option, minute inverse is given. So I need not do any conversion into seconds or whatever it is. Now here 0 and 0 cancel. 4, 5. So we need to do 2.303 by 10 log 5 by 4. So that means log 5 minus log 4, right? So then we have log 5 value we have, log 4 value we have 0.6990 minus 0.6020. Okay. So we have 0.097. So K is equal to 2.303 by 10 into 0.097. So now what you can do is, you can do the simple calculation. So first what you can do, instead of going to these decimals, it is easy to multiply larger numbers. So what I can do is, I shift 1 point here, I shift 2 points here and make it, okay, let me make it 23. Okay, so we have 23.03 into 9.7. Okay, and then I have shifted the points. So I get 0. Into 10 to the power minus 3. Then we have 0.0223 minute inverse. When I do the calculations, so I get this answer as the option C as the right answer when you do the calculations. Okay. Next, question number 23. The expression to calculate time required for completion of zero order reaction. Okay, there I have made the, in the previous one, I have done the calculations by taking 10. Again, if you bring 10 to the above, it will become 10 to the power of minus 4. Then when you do this calculation, you get this as the answer. Okay. Yes. The expression to calculate time required for completion of zero order reaction. So zero order reaction, we know the expression K is given as R naught minus R divided by T. So KT is equal to R naught minus R. Now we have to find out the time. So T is equal to, so R naught by K. Okay. So we have, where is a value? Yes, R naught by K. So that is the expression. The expression to calculate time required for completion. So since it is completed, so this we are ignoring that particular concentration of R because there is no R left at that particular time since we are talking about completion. So T is equal to R naught by K. So the correct answer is option A. Next, question number 24. The rate constant of a first order reaction is given, that is K value is given 15 into 10 to the power of minus 3 second inverse. How long is asked? So time is asked. Will 5 gram of this reactant take to reduce to 3 grams? So A is 5 grams. A minus X is 3 grams. Okay. So now again do the calculations. K is equal to 2.303 by T log A by A minus X. K is given, but T has to be found out. So let me do the rearrangement. 2.303 by K. K is 15 into 10 to the power of minus 3 log of 5 by 3. Correct? So again, this log of 5 by 3 can be written as, let me just write 2.303 by 15 into 10 to the power of minus 3 log 5 minus log 3. Okay, so log 5 minus log 3. So we have 0.6990 minus 0.477191222. So 0.2219. 2.303, 15 into 10 to the power of minus 3 into 0.2219, right? So now I can also shift the points. I'll do the shifting of the points so that it will be much easier for me. So here we have, let me shift this point here, 1. Let me shift the 2 points here so that I have 23.03 into 22.19 divided by 15 into 10 to the power of minus 3. Here I have totally shifted 3 points, so 10 to the power of minus 3. So this both cancels, right? So now instead of going into decimal points in detail, so here we have 23.03, here we have 22.19. So I'll directly do 23 into 22, okay, for my easy finding of the answer, so that to cut down the time that is required for solving of the problem. 2 3s are 6, 2 2s are 4, 2 3s are 6, 2 2s are 4, again 6, 10, so 5 naught 6. So 5 naught 6 divided by 15, so that you get approximate value, so that it will be easy for you to identify, okay, what is the answer. So 15 3s are 45, we have 56 again. So this is almost equal to 4 times, okay. Almost equal to 4, 15 fours are 60, but almost you get 33 point or 34. So we have this answer, whereas all other options does not come around 30 at all. So by looking at the option itself, you can identify what is the right answer. Instead of going into detailed point-wise calculations, multiplication and finding out the answer, just do the approximation and find out the answer. Okay. Next, question number 25. In a first order reaction, the concentration of the reactant decreases from 400 mole per liter to 25 mole per liter in 200 seconds. Okay, so very simple. Here 400 mole per liter is equal to A and 25 mole per liter is A minus X. Correct. Time is given 200 seconds. And even in the options, it is second inverse. So no need to do any changes with respect to the time. So rate constant K is asked. So K is equal to 2.303 by T log A by A minus X. So we have 2.303 by T is 200 into log of A is 400 divided by A minus X is 25. So 25 ones are, 25 16s are. So we have 2.303 by 200 log of 16. So 16 is nothing but 2 to the power of 4. So I can write it as 2.303 by 200 according to the log rules. So we have log 2 to the power of 4 is equal to 4 into log 2. Okay, so I bring 4 this side into log 2 is nothing but 0.3010. Correct? So we have this particular answer. Now do the calculations. Okay, so 2.303 into 4 we have into 0.3010. So here I can also write it as, again, I'll shift the points to make it much more simple. Let me shift this point. Let me shift 2 points here so that the calculations are much better. So this also I'll make it by 2. I shift the points here and make it 10 to the power of 2. So I have 23.03 into 4 into 30.10. Totally I have shifted 3 points. So minus 3. 2 into 10 to the power of 2. Correct? So now I can easily just check 23 into 30 into 4. So let me do the calculation. 23 into 30. 9, 3 2s are 6. 3 3s are 9, 3 2s are 6. So 690. 690 into 4, 36. So 2760. So 2760 divided by 2. So you have 2 ones are 2 ones are 2 threes are 6, 8, something like this. 1.1380 you get. So 1380. Look at the these 10 to the power of whatever has been taken. Here it was 10 to the power of minus 3. Now this in the denominator you have 10 to the power of 2. When I bring it up, it becomes minus 2. So total it will be minus 5. So 1380 into 10 to the power of minus 5. So I need to shift the points. Okay. So if I shift 1, 2, 3. So I get 1.38 into 10 to the power of minus 2. So we have this as the correct answer. So if, by the time you get this particular answer itself, you can easily select this as the option C as the right answer. Okay, no need to go much into detail with respect to the decimal calculations. Next, question number 26. A first order reaction takes 40 minutes for 30% decomposition. What will be the T half? Correct? So 30% decomposition has been already done. Okay. So since percentage is given, I'm taking A as 100. A minus X will be 30% has been already decomposed. So how much is remaining? It is 70. 100 minus 30. Then what else is given? First order reaction is mentioned. So the equation corresponding to the first order reaction has to be taken. T half is asked. Right? Now first, let us write the equation for K. K is equal to 2.303 by T log of 100 by 70. So this both will cancel. 0 and 0 can be cancelled. So we have K is equal to 2.303. The time is given 40 log of 10 minus log of 7. Okay. So we have the log of 10 is nothing but 1. So let me write it. 1 minus log of 7. I told you need to remember. So 8451. So we have 0.1549. So this value we already have 2.303 into 0.1549 divided by 40. That is nothing but K. Now the question is you have to find out the T half. Correct? So I can write T half for a first order reaction. We know that it is 0.693 by K. Now I directly substitute K value in this equation. So T half is equal to 0.693 by K. So 2.303 into 0.1549. Now this 40 will go to the numerator. Now let me shift the points. 2 points here. Let me make it 69.3 into 40 into 10 to the power of minus 2. Now here Here also, let me try to shift the point so that multiplication becomes easy. Here I shift 2 points. So 23.03 into 15.49. I have totally shifted 3 points. So minus 3. So here we have, let me just do the approximate multiplication. Okay, so 69.3 into, yeah, into 4 I can do so that, wait. So here I have shifted 2 points, but this I can also write it as 4 into 10, 10. So I'll make it as minus 2 will become now 10 to the power of minus 1. Right, I hope you understood how I have made it as. I'll take it as 4 into 10 to the power of minus 1. Okay, instead of 14 to 10 to the power of minus 2, I make it 4 into 10 to the power of minus 1. Okay, so now I can directly do 69.3 into 4. Okay, 36, 37, 27. So I have 277.2 in the numerator. Let me just continue the problem here. 277.2 into 10 to the power of minus 1 divided by, in the denominator, we have 23 and 23.03. So again, I'll do the approximation into 15.49. So let me approximate to 15.5. So 23 into 15.5. So we have 5 plus 5, 23, 3565. Okay. So we have now 3565 into 10 to the power of minus 3. Right. Here I've shifted 3 points. So this was minus 3 here. So now 277.2 divided by 3565. So you get the answer when you do the calculations. So let me again shift the point. So 277.2. So when you shift the point and when you do the calculations, so by division, you get 0.77 into 10 to the power of 1 as the answer. Because this, when you shift the here, when you shift 1 point, this becomes minus 2. And when you take minus 3 above, you get 10 to the power of 1. Then you get the answer as 0.77 into 10 to the power of 1 is 77. So approximate, since we have taken many approximations, you get the approximate value. But when you look at the options, you can easily find out that option A is the right answer. Right. So here, since I've shifted the point and made it minus 2, I do the calculation of division 7, 2. So 3565. This is just for your clarification. So it goes 0. Then I'll add one more 0 here. So 7s are. So we have 24955. So I have 2765, 2765. So again, when I make it 0, again I get 24955. So 0.77 into 10 to the power of 1. How I got 10 to the power of 1? Because here it was minus 2, here it was minus 3. When I bring it above, it becomes plus 1. Okay. Yes. Next, question number 27. A first order reaction has a rate constant 1.15 into 10 to the power of minus 3. So K is given as 1.15 into 10 to the power of minus 3 second inverse. How long will 5 gram of this reactant? So A is 5 grams. Take to reduce. So T is asked. Reduce to 3 gram. Now it is reduced to 3 grams. So A minus X direct value is given. That is 3. So again substitute the value. K is equal to 2.303 by T log of A by A minus X. Now K is given. T is asked. So do the rearrangement. T is equal to 2.303. K value is 1.15 into 10 to the power of minus 3 log of 5 by 3, right? So now again, you need to remember, as I already told, log 5 and log 3. So log 5 minus log 3 we are going to do. So log 5 is 0.6990. Log 3 is 0.4771. So we have 0.2219. So time is equal to 2.303 into, this simplification has already been done, 2219 divided by 1.15 into 10 to the power of minus 3. Now again, do the shifting of the point so that it will be much easier for us to do the calculation. So let me shift 1 point here. Let me shift 2 points here so that 23.03 into 22.19. I've shifted 3 points, so minus 3. Here, I can again make it as 11 so that it is easier for calculation. So I'll shift 1 point here, 11.5 into 10 to the power of minus 4. Now, 23.03, 22.19. So I can directly do 23 into 22. 2 3s are 6, 2 2s are 4. 2 3s are 6, 2 2s are 4 again, 6, 506. So 506 divided by 11.5. I have to do 506 into 10 to the power of minus 3 divided by 11.5 into 10 to the power of minus 4. Right? So again, we can shift the points here again. Okay, so we have 5060 divided by 115. Okay, so before that, I can also do the simplification. Okay, here mainly remember we are doing the approximation because if you go for detailed calculation with respect to the decimals, it will take a long time. So 5 ones are 0, 1, and 5 twos are. So then we have 5 twos are 10, 5 threes are 15. Yes. So then we have 1012 divided by 23. Yes. So we have the answer as, yes. So 1012 divided by 23. So you almost get around. So divided by 23. So you have 23. Yeah. 23 into 4 times, you get 92. Right? So then we have again 4 times. So 44 into, now 10 to the power of minus 3 is there. This 10 to the power of minus 4, when you bring it up, becomes 4. So 44 into 10 to the power of 1. So almost 44 into 10. So 444. There's something like this. Because 44 is there, so it cannot be 400. So of course, the correct answer should be option A, 444. Okay. Next. Which of the following statements about the catalyst is true? A catalyst makes the reaction feasible by making delta G more negative. Now they have asked which is true. This is not the correct statement. A catalyst makes equilibrium constant more favorable for forward reaction. No, it brings about the changes both in forward and backward reaction so that equilibrium reaches faster. It's not favorable towards one type, that is one forward reaction only. It's not like that. That is wrong. Okay. A catalyst accelerate rate of reaction by bringing down the activation energy. Yes. So option C is the right answer. A catalyst always increases the rate of the reaction. No, there are certain negative catalysts which bring about the decrease in the rate of the reaction. Next, question number 29. A plot of log A minus X against time T is a straight line. This indicates the reaction is off. Okay, so now log A minus X is there, time is there. So what does it indicate? So we know that this A minus X, mainly let us take the example, let us take the equation of first order. Okay, log A by A minus X. So K is equal to 2.303 by T log A minus log A minus X. So I can also write it as KT divided by 2.303 is equal to log A minus log A minus X. Now I can also write it as log A minus X is equal to log A minus KT by 2.303. Now this will be Y is equal to, this will be mx, this will be c. So it is in the form of y is equal to mx plus c. So it is already given as it is a straight line. So t is along the x-axis. This is y. So we have this as the slope and this as the intercept. So of course we have started with the first order reaction. So the correct answer is option B, that is first order reaction. Okay. Next, question number 30. Match the graphs given in column 1 with the order given in column 2 and mark the appropriate choice. So this I already told. I've also explained much in detail in the explanation video of this chapter. So please be very thorough with the graphs and which order of the reaction do they suggest. Okay. Now you see here 1 by a square. Very simple. When this term is there, be very sure it is of the third order. So we have D for 1. We have only one option with D for 1. So you can easily eliminate the other options. But let us confirm with the other options as well. Okay. So 1 by A. If 1 by A square is third order, 1 by A will be second order. Correct. So C for 4. Right. Then we have log A versus T. Okay. That is for the second order. That is for the first order. And then we have concentration versus time, where it goes again, the graph slopes downwards, which is for the 0 order. So A for 3, B for 2. So correct answer is option B. Yes. Next, question number 31. Half-life period of a first order reaction is 10 minutes. So T half is 10 minutes. What percentage of the reaction will be completed in 100 minutes? In 100 minutes, how much percentage will be completed? Now this 100-minute, if you observe carefully, it is nothing but 10 into T half. So this equation I had already explained when I was giving some additional formula in the explanation part of this particular chapter. I told you to remember a few things. Whenever we consider 10 into 10 half, that means this time is required for the completion of 99.9% of the reaction. Okay, this equation I've explained in detail. So by looking at this question itself, we can easily select the option C, 99.9%. Next, question number 32. The half-life for radioactive decay of C14 is 5730 years. So T half is 5730 years. An archaeological artifact containing wood had only 80% of the C14 found in a living tree. Okay, so only 80% was remaining now. Okay, so 20% has already been, it has already reduced, it has already reacted, or it has already been removed. Okay, only 80% is remaining now. So what is remaining at time t? It is 80. Okay, so out of 100, only 80 is remaining. So A minus X will be 80. A will be 100. Correct? Now, the age of the sample. So age of the sample means we are finding out what is T. Okay, so but they are given the T half. Now using T half, what you can find out? You can find out what is K, right? So let us first write the equation for T half. T half is equal to 0.693 by K. So you can write the equation for K. K is equal to 0.693 divided by T half, that is 5730. Now substitute this K value in the first order reaction. So K is equal to 2.303 by T log A by A minus X. Now you have to find the age of the sample, that means T. So let me rearrange the equation. So 2.303 by K it will be into log of A by A minus X. So T is equal to 2.303. Now K can be written as 0.693 divided by 5730. So it will go to the numerator 5730. So let me write here 5730 into log of A is 100. A minus X, as I already told, it is 80. So cancel. 4s are 5. So log 5 minus log 4, it will be 0.6990 log 5. Log 4 is 0.60207. Okay, 0.097. So do the simplification now. 2.303 into 5730 into 0.097 divided by 0.693. So this is the equation you need to find out. Now, 2.303 by 0.693 is almost equal to 3.32. This you can memorize, okay, so that for you it will be easy to do the calculations quickly. So this is almost equal to 3.32. So I'll write it directly. So 3.32 into 5730 into 0.097, right? So now let me find out for 5730 into 3.32. So we have 5730 into 3.32. So 2 3s are 6, 2 7s are 14, 2 5s are 10, 11. Okay. So we have again 0917 plus 17. So I have 19023.60. Now this into, now what is remaining? Again, I can shift the points and make it 9.7. So I get 19023 into 9.7. So when I do the calculations, so 7 3s are 21, 7 2s are 14, 16, 7 9s are 63, 7 1s are 7, 133. So then again we have 9 3s are 27, 20. So we have 2, again 81. So 17. So I have 3, 2, 5, 4, 8, 1. So I can now shift the point. Yes, I have 184523.1 into 10 to the power of minus 2 because I have taken it as 9.7. So minus 2 means if I have to make it again normal, I have to shift back the points. So 1845. So I got the answer as 1845. That is option B. Okay, so wherever possible, try to do the approximation and do the calculations because with the decimal point, it will take more time. Now next, question number 33. In a first order reaction, the concentration of the reactant is reduced to 1/8 of the initial concentration in 75 minutes. Okay, so we have the particular formula. This also I have explained in the explanation video. So whenever the fraction is given, we have T is equal to 2.303 by K. Directly you're taking log of that particular. Now, if it is 1/n, you're directly taking it as log n. So n here, I'm taking it as log of 8. Okay. So in 75 minutes, so T value, T is 75 minutes and temperature is given at 298 Kelvin. What will be the half-life period? So let me write for, again, K is equal to 2.303 by T is 75. Log of 8 is log of 2 to the power of 3. So 2.303 by 75 into 3 log 2, 2.303 by 75 into 3 log 2 is 0.3010. So when you do the let me just keep it as such, that is K. Now T half is 0.693 by K. So they have asked you to find out the half-life. So T half is equal to 0.693. Now substitute the value of K, 2.303 into 3 into 0.3010. 75 will be taken above, right? Now let me shift the point so that calculations are easy. So since I've shifted 2 points, 10 to the power of minus 2. Now here also let me shift the points. Let me make it 23 and let me make it here 3. So I'll shift 2 points, make it minus 2 again. So these two will cancel. So 69.3 into 75 divided by 23.03 into 3 into 3.010. This is what you need to do. So let us do the simplest calculations as much as possible so that it will be easy. Okay, so directly I'll take 69 into 75. Again, the approximation I'm taking 45, 5 6 are 30, 34, 7 9s are 63, It's 9, 6 times of 42. So 48. Okay. So we have 5175 in the numerator. Then we have here, I can directly do 23 into 9. Okay. So I directly do it. So that during approximation, it is much easier. So 27, 18, 19, 20, 207. Okay, so 5175 divided by 207. So again, approximation here, 5175, 207. So 207 twice it goes, so 414. So 301. So then we have 5 if I bring it down. So you can easily approximate 200. This is around 200. This is around 1000. So of course it should go 5 times. So we have 25 minutes as the answer. Okay. Yes. Question number 34. The time taken for 90% of a first order reaction to complete is approximately. So here also we are going to use the approximation method. I've given you the formula. So for 87.5% completion, the time taken, we have 3 into T half. Similarly, for 93.75% completion, we have 4 into T half. Now you can see here 90% is given, which is in between these both. So of course, the T half, the value of what we have to be multiplying with the T half should be between 3 and 4. Correct? So now you cannot be 1.1, it cannot be 2.2, it cannot be 4.4. It should be a value between 3 and 4. So of course, the correct answer is option C, that is 3.3 times that of the half-life. Next, question number 35. Which one of the following is wrongly matched? Saponification of ethyl acetate. So second order reaction, yes. Okay, so you have to see which one is not correct. Hydrolysis of methyl acetate, pseudo unimolecular reaction, yes. Okay, it is an ester again. Next, decomposition of H2O2 first order reaction, yes. It will decompose into the respective products. Combination of H2 and Br2 to give HBr, it is not a zero order reaction. So which one is wrongly matched? Option D. Next, question number 36. The unit of rate and rate constant are same for a. So this can be expected. Okay, and please remember, very, very simple. Here, rate is given as k into r to the power of 0. So k, so unit of k for 0, for which order reaction? For this reaction, which is equal to that of the rate constant. Rate constant as well as rate, which one has same unit they are asking. Okay, so here we know that rate is equal to k. So of course, in this case, in the zero order reaction, we know that overall the unit for both of them should be the same. And for zero order reaction, we know that mole per liter, that per second, that is the unit. So especially even when we are writing for the concentration, that is the unit. Concentration per time, that is for rate. So only for the zero order reaction, we have rate and rate constant having the same unit of mole per liter per second. Next, question number 37. In a pseudo first order hydrolysis of ester in water, the following results were obtained. What will be the average rate of reaction between time interval 30 to 60? Okay, again, very simple. So pseudo unimolecular reaction. So that means we are not considering the concentration of water. We are only considering what is the concentration of ester. So rate is equal to delta R by delta T. So delta R is how much? So between 30 to 60. So this minus this. So we have minus 0.14. That is 0.17 minus 0.31. Then we have delta T. So 60 minus 30 is 30. Okay. So let me shift the points for a better division. So 14 by 3000. 0. Again 0. Again 0. So 3000. 4 times we have 12,000. So we have 2,000 as the remainder. Again, I need to put one more 0. So 3, 6 are 18. So of course, 3006 times we have 18,000. Again, it repeats. So we have something like 0.004666 and it goes on. Okay. So we have, if I shift the point this side, 1, 2, 3, right? So if I shift the point towards this side, we have, I've shifted the point. So I have 4.6. Since it is 666, I can round it off to 4.67. 3 times I've shifted the point, so minus 3. So we have 4.67 into 10 to the power of minus 3 mole per liter per second. Okay. Yes. Next, coming on to question number 38. The decomposition of dimethyl ether is fractional order reaction. The rate of the reaction is given by, so already they've given the rate of the reaction. If pressure is measured in bar and time in minutes, then what are the units of rate and rate constant? Now we know that rate is equal to K into CH3 OCH3 to the power of half. The unit of rate will be bar per minute, right? Now, K will be rate by P to the power of half. Now, bar per minute is for unit of the rate. Now, P to the power of half. So, P is pressure. So, bar to the power of half. So, bar to the power of 1 minus bar to the power of half. 1 minus half. Minute inverse. So we have 1 minus half is half. So bar to the power of half into minute inverse. So that will be the rate. So rate as well as this is the rate constant. The unit for rate as well as rate constant. Now you can see here for rate we have bar per minute, correct? So instead of concentration, we are taking the pressure since it is given in pressure. So that's why instead of mole, the concentration mole per liter, we are taking it as bar. So bar per minute. So that will be for the rate. So bar per minute, we have these three options. So this you can easily remove off. Next, K is equal to rate by the concentration. Again, since we know that the concentration here to the power of half is there. So instead of concentration, I'm taking the pressure. So that's why P to the power of half. So pressure is represented in bar. So then do the respective adjustments, the calculations with respect to the numerator and denominator. So we get bar to the power of half, minute to the power of minus 1. So bar to the power of half, minute to the power of minus 1. So option D is the right answer. Next, question number 39. The energy diagram of a reaction P plus Q gives R plus S is given. What are A and B in the graph? So this is again very simple. See here. The reactants, they gain energy. They form activated complex. Now they lose energy. The activated complex lose energy and forms the product. Right. So this particular energy from the reactant to form the activated complex, this energy, A, is the activation energy. So we have only one option with the activation energy. Now we know that this particular difference from the reactant and the product, now we know that the product is more stable than the reactant by the release of the energy. So of course that is the heat of reaction. Next, question number 40. The temperature dependence of the rate of a chemical reaction is given by the Arrhenius equation. Which one will be the straight line? Which of the following graphs will be a straight line? So we have the equation K is equal to A into e to the power of minus EA by RT. So I can also take ln K is equal to ln A minus EA by RT, right? So now we have, since in all the cases they have only mentioned about ln, so no need to convert it into log again. So ln K, if I take it as y-axis, ln A will be the intercept, that is C. Now, T is in the denominator, so 1 by T will be x-axis. And we have the slope as EA by minus EA by R. Okay, so which one will be a straight line? So ln K should be taken as y-axis. 1 by T should be taken as the x-axis. So we have the correct answer, option C. Okay, whereas ln A is nothing but the intercept. So you cannot plot intercept with something else, right? Next, question number 41. The temperature dependence of the rate constant K is expressed as K is equal to A e to the power of minus EA by RT. When a plot between log K and 1 by TR is plotted, we get the graph as shown. What is the value of the slope? Now we have to convert this equation into log. So log K is equal to log A minus EA by 2.303 RT, right? When I convert it into log. Now we have again log K as Y along the y-axis, then 1 by T, right? If this is 1 here, 1 by T, this is taken as the x-axis. This is the intercept C. So we have this as the slope. So slope is minus EA by 2.303 R. So minus EA by 2.303 R, that is option B. Next, question number 42. The decomposition of a hydrocarbon follows the equation K is equal to 4.5 into 10 to the power of 11 second inverse e to the power of minus 28,000 by T. What will be the value of activation energy? So let us write the equation. K is equal to 4.5 into 10 to the power of minus 11 second inverse e to the power of minus 28,000 by T. So let us compare with the equation K is equal to A into e to the power of minus EA by RT, right? So now we have, according to this equation, so it is very clear that A value is already given, that is 4.5 into 10 to the power of minus 11 second inverse. Now T is already there. So minus EA by R is equal to minus 28,000. So that means EA by R is equal to 28,000. Correct. So now what I can do is to make it, to find out what is the value of the activation energy. You have to find out what is EA, right? So I have to multiply this value by R. So EA is equal to 28,000 into R. So 28,000 into 8.314. So we have 8.314. Let me again shift the points so that calculation is easy. 28 into 10 to the power of 3 into 8.314. So 8.314 into 28. So 32, 11, 25, 66. Now we have 2 4s are 8, 2 1s are 2, 2 3s are 6, 2 8s are 16. 9, 7, 12, 13, 2, 3, 2, 7, 9, 2. Again, I can write the points here. So 232.79 into 10 to the power of 3. 792 is there into 10 to the power of 3. So I can shift the points this side. So now you see here. So 10 to the power of 3 means this many joules. So I can also write it as 232.79 kilojoules. Right? 10 to the power of 3 means kilo. So of course we have 232.79 kilojoules per mole. Okay? Yes. Next question number 43. Match the column 1 with column 2 and mark the appropriate choice. This is one of the easiest and simplest question. So for zero order, we have this as the equation. K is equal to 1 by T into concentration of A naught minus A, that is the initial concentration minus the concentration at time T. For first, so we have for A 4. Okay, so with this itself, we got the answer, but let us confirm with the other options as well. So first order reaction, we have K is equal to 2.303 by T log of A naught by A. A naught is the initial concentration. A is the concentration at time T. So this we have used so many times in this particular lecture itself. So for B, we have 3. Endothermic reaction, of course, here reactant products are having more energy when compared to the reactant. So energy is absorbed during the reaction. So C for 2. Next, we have Arrhenius equation. K is equal to A e to the power of minus EA by RT. So we have option A as the right answer. Next, question number 44. For a reaction A2 plus B2, gives to AB. The figure shows the path of the reaction in absence and presence of the catalyst. What will be the energy of activation for forward reaction and backward reaction? See, now let me mark it in the graph very clearly. So these are the reactants. This is the product. This is the activation complex. Now, this is in the presence of the catalyst. This is in the absence of the catalyst. Now here, this will be the activation complex in the presence of the catalyst. Now, what is asked? In the presence of the catalyst, what will be the what will be the activation energy for the forward and backward reaction? Now, in the presence of the catalyst, see here, this was the initial energy of the reactant, 60 kilojoules per mole. Now, in the presence of the catalyst, activation energy it is just reached till 70, activated complex. So what is the activation energy? Activation energy is nothing but the difference, right? Difference between the energy of the activated complex and the reactant. So 70 minus 60 is 10. So 10 kilojoules per mole. Where is the, yes, here we have for forward reaction. Now, for backward reaction, what will be the activated complex? So backward reaction means from product to reactant. So product, what is the energy? 50. To form the activated complex, so what will be this difference? Activated complex energy is 70. So 70 minus 50 is 20. So for backward reaction, it will be 20 kilojoules per mole. Then what else is asked? Delta H. So delta H is the difference in the energy between reactant and product. So reactant energy is 60, product is 50. So of course, we have 50 minus 60, that is minus 10, because the energy of product is lesser. So endothermic, so delta H will be negative. So minus 10 kilojoules per mole. So option B is the right answer. Next, question number 45. The rate constant is given by the equation K is equal to Pz e to the power of minus Ea by Rt. Which factor should register or decrease for the reaction to proceed more rapidly? If T is reduced, the rate also decreases, or the rate of the reaction decreases because of the decrease in temperature. Z also cannot be reduced because it is a collision frequency. So if it reduces, then again, the rate of the reaction decreases. Activation energy, if it is decreases, if it is decreased, then what happens? The reaction proceeds faster. So the energy or the activation energy should be decreased so that the rate of the reaction increases. P is nothing but the orientation. Orientation should be well, okay, with respect to the steric factors. If it is decreasing, then of course the rate of the reaction will not increase. Next, question number 46. Rate of a general reaction A plus B gives products can be expressed as follows on the basis of collision theory. So ZAB e to the power of minus Ea by Rt. Which of the following statements is not correct for the above expression? Z is collision frequency and is equal to the number of collisions per second per unit volume. Yes, this is correct. E to the power of minus Ea by Rt is the fraction of molecules with kinetic energy equal or greater than Ea. Yes, this is also correct. Ea is the activation energy of the reaction. Yes, all the molecules which collide with one another are effective collision. This is wrong. Not all the molecules, the collisions are effective, right? So they have asked you to find out which one is the wrong statement. So of course, option D is the wrong statement. Next, coming on to question number 47. Yes. Consider the reaction N2O5. Yeah, N2O5 gives 4NO2 plus O2. Yes, 4NO2 plus O2. In the reaction, NO2 is being formed at the rate of, this is given. What is the rate of the reaction at this time? So that is what is being asked in the question. So first let us write the equation. 2N2O5 gives 4NO2 plus O2. This is the equation that is given. So rate can be written as 1 by 4 into concentration of NO2 divided by dt. So in the reaction, NO2 is being formed at the rate of this much. It's already given how much it is formed. The rate of formation of NO2. What is the rate of the reaction at this time? So directly you're going to calculate using this. The rate is equal to this one, right? Formation 1 by 4 into change in concentration of NO2 by time. Change in time. So 1 by 4 into concentration of NO2 is 0.0125. So directly you're doing the calculations. So 0.0125 divided by 4. So again, I can shift the point 1, 2, 3, 4. Here also, I'm going to shift the point 4 times. So 1, 2, 3, 4. Okay. So 125 by 40,000. So 0, 0, 0, 0. Again 0 and 0 here. So 3 times 12 lakh. So we have, yeah, 5,000. Again, I make it a 0. So ones are 40,000. Okay, again, it goes on. So I have these numbers now, 0.0031. So already it is there in the option, 0.0031 mole per liter per second. So option B is the right answer. Next, question number 48. The rate of the reaction A plus B plus C Gibbs product is given by R is equal to minus dA by dt is equal to K A to the power of half, B to the power of half, C to the power of 1 by 4. So directly it's given in the question itself. So order of the reaction, you just need to add the powers. Half plus 1 by 4. All these are reactants, so you can directly add. So 4, 2 plus 2 plus 1. So 5 by 4. So correct answer is option D, that is 5 by 4. Direct substitution. Okay. Next, for the reaction N2O5 gives 4NO2 plus O2, the rate of the reaction can be expressed in terms of time and concentration by the expression. So here, minus half should be there. Here we have minus half. Here we have minus half. Next, here there should be 1 by 4. 1 by 4 is there. Here 1 by 2. So, of course, this is not the answer. This is not correct. So, this is option B. Next, for a reaction, I minus plus OCl minus gives IO minus plus Cl minus in aqueous medium. The rate of the reaction is given by. Now again, we have these 1, here 1. Here it is in the denominator. So of course it will be minus 1. So order of the reaction will be 1 plus 1 minus 1. Look at the powers that are given. This is in the denominator. So you have to take it as minus 1. So 2 minus 1, which is equal to 1. So the overall order of the reaction is 1. Okay. So these are the various questions with respect to the chemical kinetics chapter. I have selected 50 multiple choice questions, which are very important. And I have selected in such a way that there are variety of problems that are solved in this particular video. So go through each of the question, practice well, okay, and also especially remember the values for log 2, 3, 4, 5 as well as 7, so that it will be very helpful to reduce the time that is used for various calculations, especially with the problems related to first order reaction. Okay, so I hope this video is helpful to you all. So thank you for watching the video. Subscribe my channel, SG Chemistry Lecture, for more such informative videos. Thank you so much.